Ladies and gentlemen, I would like to welcome you to the first part of the EXA4MIND webinar, Supercomputing with Versatile Data Backends. The webinar is given by Mohammad Hayek, EXA4MIND Work Package 2 Lead, and by me. I am Stefan Hachinger, the Science and Co-Design Coordinator of EXA4MIND. We are both from Leibniz Supercomputing Center in Germany. First of all, I would like to introduce you a bit to EXA4MIND as a project and to its overall technical objectives. Our project has been set up to enable industry, SMEs and researchers to leverage the European supercomputing centers for extreme data analytics workflows. To this end, we would also like to facilitate the usage of innovative data backends, by which we mean databases and object stores. The project provides an open platform of flexibly deployable modules and submodules. In other words, we have repositories openly available with infrastructure scripting and software, and you can choose and deploy what you need to boost your data analytics use case. Our modules include object store and database system installation recipes, an advanced query and indexing system module which helps you to implement analytics workflows with features such as inferencing, cross-system queries, data staging and caching, and a module for integration of data stores with international data spaces and data ecosystems such as EUDAT, the European Open Science Cloud, or European data spaces. The EXA4MIND architecture which helps us to reach these aims is shown on this slide. In the lower left part, you see a toolboxes module with validation tools, pre-processing tools, and analytics and AI tools. These tools can be used in extreme data workflows which are orchestrated within the AQIS, the Advanced Query and Indexing System, by Apache Airflow and Dask, which you see in the middle. Below the AQIS on the diagram, we have the data layer, which consists of object stores and database management systems that you can deploy flexibly with instantiation recipes provided by us. For compute orchestration across European computing systems, we rely on the Lexis platform, as shown in the lower right corner of the scheme. On top of it all, we have a layer that facilitates data sharing and data publication through international data ecosystems. Let's discuss the AQIS in some more detail, as it is essential for actually making use of data stores and analytics tools. It is used in every EXA4MIND application case, as it provides components to automate extreme data workflows. It uses Apache Airflow and Dask to orchestrate and to script these workflows. Thus, you're enabled to execute queries across different data backends. We provide adapters and tools to manage these backends, and we provide capabilities to query them in natural language. A further core idea of the AQIS is the ability to offload inference and analytics tasks to the large systems at supercomputing centers. Recently, we presented an inference server framework that makes use of the power of high-performance computing clusters. Last but not least, AQIS submodules help with data staging and caching, as well as data streaming. In this webinar, we would now like to give you a feeling on what you can do to enhance your data analytics using innovative data backends. This means going beyond file-based storage towards object stores and databases. The first part of this webinar will thus give you an introduction to S3, a popular object store scheme, and an introduction to different database types. We concluded with an overview of our offers which help you to leverage such systems and to set them up on supercomputers, on clouds, or on your local machine, you name it. The webinar is then followed up by a part 2 on actual analytics using the AQIS, Airflow and Dask. Now I will hand over the microphone to my colleague Mohammad Hayek.
Now I will give an introduction to S3. So what is S3? It stands for the Simple Storage Service. It's a cloud-based object storage system, and it was launched by Amazon in 2006. Unlike the traditional file storage or block storage, object storage stores data as objects. And usually an object consists of the data, the metadata, and a unique key. And these objects are stored inside what is called bucket and is accessible via HTTP REST API or different SDKs. What are the advantages of using S3? Additional solutions such as SAN or NAS are expensive, inflexible, and hard to scale. Every time you would need to scale that, you would need to buy a new machine and set it up. As for S3, it provides scalability. You can store billions of objects. Its durability, it ensures very low rate of data loss. It's cost efficient. It replaces the upfront storage purchases of machines and global access. Thanks to its HTTP-based API, it can be accessed from anywhere. And it follows the cloud-native design for modern design of systems. What are the disadvantages of using S3? The latency. Due to the HTTP nature of S3, it's slower than the traditional storage. As for cost management, it can get expensive if it's not optimized. Complexity, all the access policy and the bucket policy can be tricky sometimes, and you might end up in a lock-in situation because of data migration from one provider to another can be expensive. What are some S3 compatible implementation? All these are open source, such as MinIO, Ceph Redis Gateway, OpenStack Swift with S3 API, S3 Proxy, Versity Gateway. And now we will talk about a real-life use of S3. S3 is used by Netflix. Netflix uses Amazon S3 to store and serve billions of images, videos, and take advantage of the ability to scale its storage capacity to deliver performance to meet the global demand of users all around the world. Airbnb, it uses Amazon S3 to store and manage the data generated by its user. That includes the user profiles, listing, reservation information. As for Expedia, it uses Amazon S3 to store images and videos for the travel listing, and it allows seamless user experience to the customer even during the peak traffic times where everyone are booking flight, example around a Christmas vacation or summer vacation. I will dig deep into the Netflix use case. The Netflix architecture is based on a microservice architecture. The core backend is made up of more than 1,000 services. It's fully cloud native. It's hosted on Amazon Web Service, AWS. It has elastic scalability and global availability. As for the data storage, they are using Cassandra, a distributed NoSQL database. For high write throughput, they are using MySQL for relation database needs. They are using S3 for storing of the data, the media, the logs, and DynamoDB for a key value storage. So how does Netflix use the S3? The admin wants to upload a fresh new episode or a certain movie. So they start that by adding metadata, including the tags, the titles, and the description of the episode or movie. These metadata are stored in an Elasticsearch OpenSearch database, which is known for its fast search. After the admin has hit the upload button and the video is uploaded, it goes to a certain S3 bucket. Once that happens, the video is converted into various sizes so that it can fit the screen of every user. And that includes 4K, 1080p, 720p. The videos, once initially uploaded, are stored in the frequently used Amazon S3 bucket. Movies or episodes that are not frequently watched, they get transformed to what's called the chill zone, and that's based on the S3 glacier of Amazon. This storage switch up not only ensures that costs are kept low, but also make sure that the resources are used in the best possible way. Now I will give an introduction to databases. So what is a database? A database is an organized collection of data. It is managed through a database management system called DBMS and provide the following key functions. It provides the data storage and retrieval, transaction, security and access control to this data, and scalability and availability. So any system that meets these criteria is called a database. And in that case, an Excel sheet will not be called a database. What are the different types of database? We have relational database, example, MySQL or PostgreSQL. We have NoSQL databases, example, MongoDB, Cassandra, Elasticsearch. We have time series database, used for IoT, like InfluxDB, and we have vector databases like Milvus or Pinecone. An example of a relational database is MariaDB. It's an open source relational database, and it's a fork of MySQL. It supports SQL and ACID transaction and is known for its high performance, security, and enterprise grade feature. Postgres, it's another type of database. It's open source, it's relational database system. It supports advanced SQL feature. It's also ACID compliant and put data in JSON format. It's known for its extensibility and strong community support. MongoDB, this is a type of a NoSQL database, and it's document oriented. It stores data in JSON-like BSON format. BSON stands for the binary format. It has a flexible schema. It's highly scalable and widely used in modern web applications. As for Elasticsearch OpenSearch, it's a distributed search and analytic engine. It's commonly used for log analytics or full text search and real-time monitoring. OpenSearch is the community fork of the Elasticsearch and provides similar features. As for Milvus database, it's an open source vector database designed for AI and machine learning application. It provides efficient storage and search of embedding vector and supports similarity search, recommendation, and semantic search.
In the last part of this webinar, I would now like to explain to you how we make it easier for you to leverage all this technology with our installation recipes and with our adapters to access data backends. We offer you deployment recipes for all databases and object stores that are used within EXA4MIND, and we offer them in two versions. On the one hand, for deployment on virtual or real machines, based on the management tool Ansible. On the other hand, as Kubernetes configuration files. You can easily adapt these recipes for your use cases. Then, to do actual analytics on these storage systems, you will need an interfacing to read and write data. If you want to use them from an AQIS workflow, you would surely like to talk to the data systems from your Airflow or Dask-based scripts. In the Airflow ecosystem, such connectivity is within the so-called Airflow providers. We have added providers for iRods and Milvus, as these are not within the set coming from upstream. For the AQIS Dask engine, we likewise offer adapters towards all data backends, which enable you to implement basic operations for reading and writing data. More information on the adapters is available under the documentation page that you see right under the title. Now you might say databases and object stores are classically not used in high-performance computing. That is true, and that is something that we want to flexibilize within this project. High-performance computing tasks could read data from data stores deployed on an on-premises cloud at a supercomputing center, for example. Or you could temporarily spin up a flexible data backend within an HPC cluster. In EXA4MIND, we are evaluating these possibilities, and of course, we are aware that firewalling and high expectations on performance don't make such endeavors easy. Stay tuned for more results that we are presenting, for example, on SC Asia 2026. Now I thank you for listening, and I would like to welcome you to join also the second part of this seminar, where we will show you some examples of Airflow and Dask-based AQIS workflows.